1 is find the domain of R of X.
Okay, step 1 says quickly, find the domain. And guys, you know you're not going to be able to find that domain unless you go back and simplify that function. I'm going to simplify this on the side. So we'll take out a common factor of 3x, numerator. Denominator factored into x plus 4, x subtract 3. That's the way it looks factored. Domain, x cannot be equal to -4, positive 3. Now if you leave it written like that, rather than put it in interval notation, I'm happy. Remember step 1 answer. That's my domain. Cannot let x be those two. What's step 2?
Write R of X in lowest terms.
Now that's what I just did, so I'll just repeat. We have it now in lowest terms, they call it, factored terms, like this. So just repeat, you get partial credit for all this. That's step 2. What's step 3?
Name the intercepts X and Y.
Okay, let's try to find the intercepts. Guys, I'm looking at the x-intercept. Now, if you follow the advice of a former student of mine, I know you're supposed to set the function equal to 0, and I did a cross multiplication last time. Now, the student merely said, Professor, all it comes down to is go back to your fraction, your rational function, and set the numerator equal to 0. That's a quick way to do it. Find the x-intercept. Set the numerator equal to 0. Solve this, easily done. You're going to end up with 0 here. You're going to end up with a 1 there. I prefer ordered pairs, you know how I am, and there. Those are my x-intercepts. All this is partial credit. Now y-intercept. A little bit easier. Just go back and replace, find, or replace all the x's by 0. Guys, if I do, oh my goodness, on top here, either here or here, you're going to end up with 0 on top. That looks like a -12 there, which leads me to a 0. So my y-intercept is 0, 0, which you would expect. If the x-intercept is 0, 0, the y-intercept is going to be 0, 0. Is that true?
Yeah.
So we got the x and y-intercepts, all that, and all that's a lot of credit, even before you get to the graph. What's step 4?
Determine the vertical asymptotes, if any, of the line.
There we go. Now these are vertical asymptotes. And guys, we right in our discussion said, well, you go back to this, and you know x cannot be equal to a -4, and x cannot be 3. That's where your vertical asymptotes will show up. I got 2 of those. I got to show a vertical asymptote here and here. Done. And what's number 5? That's the toughest one.
Determine the horizontal asymptote.
Now, you'll say, oh, Professor, I saw what you did right before the break, and I needed my break after I saw all that, Professor, but you showed me how to find the horizontal asymptote. I'm going to give you a shortcut. If your original rational function in the blue, if you check out the degree on the top, the highest exponent, and the degree on the bottom, and they are the same, you've lucked out. You can find the horizontal asymptote within seconds. Now, did I luck out here, guys? Is the highest exponent on top 2?
Yes.
But
If I jump down to the bottom,
is the
is
same.
it 2 again?
Yes.
If they match up, your horizontal asymptote, without going through all that business I showed you before the break, is automatically
1.
that leading
Right.
coefficient over that leading coefficient.
Yeah.
It's 3 over 1. That's where your horizontal line is going to be located, up at 3. So here, horizontal. When I finally get to the grid, I go up 3, draw a horizontal line. Now, I know what you're seeing there, and I know my students by now. I've got some clever students in this class. I've been bragging on you guys. You're probably thinking right now, well, what if they're not the same, Professor? Suppose the exponents are not the same. then there's cases for those also, which will eliminate some of that worry we had before the break. But right now, I'm gonna just focus on this one where they are. I'll let you know later on when they're not what we must do. Right now, we lucked out. Did they ask us to find a crossover point if it exists in that horizontal asymptote? We-
The horizontal asymptote will describe the end behavior of the function.
Beautiful, that horizontal asymptote does describe the end behavior. Did they mention anything else?
It's important. Is it possible for the graph to intersect or cross? its
Is it
horizontal axis?
possible to have my graph cross over, like you saw before the break, cross over that horizontal line? They call it a crossover point. It is possible. May not, but I'm gonna check here, certainly. Did I tell you how to check to see if it does?
Through sign analysis.
No, something else. No, on the handout. Did they give you anything else on the handout?
No, it goes into step 6, which is determine the oblique asymptote. This is
Okay, so it does not give you a routine how to find that crossover point if you have
I
one.
believe not.
Okay, guys, here we go. I need your help. We know the horizontal asymptote is at 3. Can someone in this clever class tell me, will my original function ever touch or cross 3? How would you find out, being clever now? Yes, professor, and then you have to name where it does that. Is it possible for my graph, which I don't have yet, this function, all I have is a function. Is it possible for this function to take on or be equal to the horizontal asymptote at some point? What would you do as a clever student to find out, yes, it does, professor, and I can tell you which point it is? Does anyone have an idea? To find a so-called crossover point, if there is one. Any ideas, guys? There's some clever students in here. Go for it.
Could an idea be using the intermediate value theorem?
No.
Okay.
Something else, easier than that. Let's use a little common sense. You'd like to know, does my original function ever take on 3? What does that translate into me as a student doing to find, is that statement true? Does my function ever take on 3? Yes?
Are you supposed to set the function?
Beautiful. You take your function. That's why I've been bragging on you guys. Take that function. There's a plus x minus 12. He described that perfectly for me. He says, professor, set it equal to 3. Set it equal to that number. And see if they are equal. Which on a graph means they will touch or cross or there's a point there in common. Set them equal and see if there is it possible. Now I gotta solve that thing. Now here I will write 3 over 1. And I am going to cross multiply. Do it fairly quick. I'm gonna multiply these two together and these two together. That's a quick way. So guys, in this direction here first, we'll merely end up with 3x squared subtract 3x. The other direction, this like this, is going to give me 3x squared plus 3x subtract 36. That's it by merely cross multiplying. Now you're supposed to solve that. If you can't solve it, if all the x's drop out, then when I get to the graph, I'm guaranteed my graph will never touch 3. Now let's see if I can solve this. I think this one we'll find out may be solvable. These terms drop out. Now I'm going to do mine like this. If I move this over as we should, you're going to end up with 6x. I'm solving the equation from across the street. If you move the 36 on the other side, I'm just moving it mine over here, that becomes a positive 36, I think. Let's move things around.
6.
Is there an answer?
Yeah.
X equals 6. So that means out at 6, when I finally get to the grid, it should be at 3. In other words, this should be on my graph. It is going to touch 3. it is going to include 3. Where? Out of 6. What do you see this graph? Now, I think that's all we need right now. We're not going to talk about oblique until later, real later. Okay, I think that's all we need. Okay, so let's graph it, guys. Put all that business together. Now, for our graphic, this will move smoothly. Here we go. Step 1, we found the domain. Step 2, we simplified the function. Step 3, we found the x and y intercept. No problem. Step 4, we found the vertical asymptotes. Step 5, the harder one was the horizontal. And I gave you a little shortcut on this one, how to find the horizontal right quickly if the degrees match up, the highest exponents. I love those. You quickly see where the horizontal is by looking at these leading numbers, coefficients, one over the other. Crossover point, a little interesting. My graph will, when I finally get to the grid, will cross over the horizontal asymptote out at 6. Now, I don't know in my mind, if I were a student and I was trying to visualize in my mind before the professor did the graph on the board, I don't know whether I could even visualize what it looks like. Until I put all these pieces together. You guys, let's see what it does look like putting all these pieces together. One side of the board, all that information. Now let's try our best to make this look reasonable. Okay, here we go. First, on the grid, you pick up on it. Let's get these intercepts out of the way. 0, 0. Right here. 1, 0. Right there. Y-intercept, 0, 0. So guys, we put a little check here. I got these done. Vertical asymptotes. There's one out at -4. Label. Spin that. The -4 is right there. And I am going now, I usually use a red marker for vertical to show that you cannot touch that at all. Oh, use this. So that out at -4, guys, we got this. Out at, where's my other vertical? Out at 3. I got it on out to 3 and draw another vertical. That's going to be here at 3. Got those. Now, am I leaving anything out or not? What else do we have? Horizontal. And this is a nice one. The horizontal is up at, I'm going to find, up at 3. So let me go up to 3, and I will try to use, I got all these markers floating around here. Let me go up to 3. Right there. We use green and show the horizontal asymptote is up here. Horizontal line is way up here. This is a nice example.
Crossover points.
Yeah, hang on. That's the horizontal. Right?
Yeah.
And then we decide also, Professor, when you start graphing, the graph's going to eventually cross over out here at 6, up 3. So I could get ready for it now. Lisa mentioned that to me. So if I want to extend this on out to 6, I'll say 4, 5, 6. I could show right now, and I'm trying to find a nice marker here, let's try it. Out 6, up 3, right here is my crossover point. Woo! Guys, do I have everything based on that over there? Do I have everything on the grid? I think I do. We're ready. Now we'll go from left to right. Sometimes after a little practice with these, you'll be able to do these quickly, but here goes. Something's happening to the left of -4. Does anyone have an idea? Without plotting points, you can always plot points. Does anyone have an idea of what's happening to the left of -4? And before you tell me, there's also something happening. Look at this mess. From here to here, from here to here, all this in between, and also to the right. So something's happening to the left of this, something caught between the two vertical asymptotes, something to the right. Let's start on the left, and the thing on the left is I have no points plotted on the left. I have nothing going on. Does anyone have an idea what shape might the graph look like on the left? Go for it, Lisa.
I can guess. I think it's from the left. It should be increase.
Okay, tell me where it is. Tell me the region. It's to the left. Is it down here? Is it up here? Let's copy to the left.
Up there, it should be.
Up here.
Yeah. It should
Hang on
be.
now. I should put it a different color if I can. Let's see. Try red. Lisa, you're saying, Professor, to follow those asymptotes, I think the graph is up there.
Yeah, I think it's.
Hang on.
Yeah.
That's to the left of that orange vertical asymptote. And it does follow the asymptotes. That's why those asymptotes are there. You have to follow them. It does follow the vertical, follows the horizontal. Now, a student may say, Lisa, I see what you're saying. Why? Here's another possibility on the left. Here. Why did I do this, Professor? That follows the asymptotes, the green and the orange. Why could it not do that? Because it does follow the asymptotes. Samantha.
Because of horizontal asymptote.
Who's something easier than that? Why do I know without plotting points? You can always plot points. Always plot points. How do I know for sure it's not following the green and the orange this way? It's like Lisa says, it's up here following the green and the orange. Why can it not be down there? You're going to cross the x-axis. If you cross the x-axis, that would give you another, where is it? X-intercept. Do I have another x-intercept? No. I've already found the x-intercept. There are no more. So I know this is out. Cannot be down there. Now, if you're not for sure, always plot points or use silent analysis, whatever you want to use. That part's done. Now, in between, this chunk, all of it, something's going on here. And you got to pick up those 2 points. Does anyone have an idea, without plotting points right now, what might that big piece caught between look like? Look like in between. Now just give me a guess and we'll break it up. Go for it.
It might look like a parabola.
Now you say parabola, describe to the class what you think it looks like. So start over here.
Yes.
Okay, so we'll go up.
It's gonna cross through the orange.
Hang on. Go across there. Can't touch that vertical. Let's go across here, then go up somewhat and come back down, pick up this. Now where's it gonna go from there?
It's gonna go back to.
Back toward the other vertical asymptote. Oh my goodness. You said, Professor, could I actually examine that a little bit closer and plot some points just to make sure it looks like that? Oh, by the way, guys, did I pick up my x-intercepts in between there? I did. I followed the vertical asymptotes that he suggested. Looks beautiful to me. Now, the last part is something to the right of this one. Where must the last piece be? It's got to follow those asymptotes. That's why they're there. Let's see in the back there. Yes?
The opposite.
Now, when you say opposite up here,
Yeah.
now, I gotta be careful. Watch carefully here. when I do what you're saying to do, and I agree with you, must I pick up this crossover point?
Yes.
Right? I gotta pick it up, there's a crossover point. Crosses the horizontal asymptote. Now, where's it gonna go after it crosses?
Should it go down?
Oh, that's what I wanted to hear. No,
Back up.
but that's exactly what I hear every semester. You say, oh, professor, it's gonna cross over. If it crosses over, it's eventually gonna come down and pick up another x-intercept. Now you gotta keep in mind, this is not an x-intercept. It can't go like that, but it is gonna cross over, and guess what it does? Guess what it does? I see your hand going up.
Well, it follows the.
It follows the green, it's gonna hover around, stay close to the green. That's why the green's there. It's gonna continue to follow that horizontal asymptote. Well, if you guys don't find this to be exciting, I don't know what's going on. Jeez. This is better than Netflix. Gee, what else have I been watching lately? TikTok? Is it TikTok? Oh, jeez. Instagram? Did I ever see anything more exciting than this? I think I'm gonna become an influencer. Mr. Park, I think I could become an influencer, and I need, that's big money. Get some people to follow me. Would you guys follow me? Yeah, all of a sudden I have 3 million people. Wow. And Professor Ramsey's doing rational functions on TikTok and Instagram and all that business. As long as my money comes in. That's it, yeah. Samantha.
Can you explain the parabola and how you solve it?
Yeah, beautiful. You could plot points now. Keep in mind, you can always plot points in between. For example, if you try 2, you can take 2 back to the original, look way back here. Plug in 2, you can use the factor form if you wish. Good question though. You plug in 2 here, you got this. A quick 5 here, I think. 6. Plug in 2. 6 and a -1. If I plug that in quickly, I tried 2, and this would give me 6 over a -6, looks like, if I did that correctly. Is that -1, guys? I did that quickly. So that says out here at 2, I should be down at -1. So does this red graph make sense? Out 2, I should be down. Or you could use sign analysis. You can set it up and use sign analysis. Or you could plot points. You see whether you're going to be above, below, whatever's going on here. Now tell me though, before I take questions, which I love, this is my last one going here. Why could this graph not do this? Sometimes they do. It goes up. By the way, notice that arrow there. It never touches that vertical. Follows it, but you can't touch it. Then it goes up. Why did it not cross here, which it should? Why didn't it just go up like that, then back up this way? Why didn't it just bounce and go back? What's wrong with me? Why did I have to turn it and come back down again?
Horizontal asymptote?
Yeah, I'd be crossing the horizontal asymptote again. Somewhere in there. And we found earlier there's only one crossover point. It's out at 6. Woo, woo, woo. This is what I want to hear. Yeah, go.
Can you plot with us like a point that can represent the part of the graph where it crosses?
Right here.
Yeah.
Beautiful. Beautiful. Here goes. Ms. Parker going to help me. Get ready. Don't you mess up. Okay. This indicates it goes out forever. The graph extends. I could grab this right here and just pull it up this way. It goes out forever. It's getting closer and closer and closer to 3 as you pull this out. It's never going to go down this way. It's going to just hover around 3 up there. And they call it a crossover point. Now I want Mr. Park to do me a favor. Mr. Park, could you please, as this red graph is being pulled along forever to the right, would you try a number for me? Put it in this form here or this form here, it's up to you. Which one's easier for you? Would you replace these x's by 1,000? replace those x's by 1,000 and see what the value is. Because that's way out there. I stopped at, like 6 here, that's 6 here. Now I'm asking him to go way out here at 1,000 to see where my graph is located. So you can plug 1,000 into the function. What'd you get?
It's like 2.994.
2.994. Is that close to 3? Is it still less than 3? Because that looks like my graph is below 3. It's hovering around below. Is it less than 3? If I ask him now, try 10,000? Try 10,000. Can you do 10,000 within seconds? Try 10,000. See what you get. 2.99 something else. A little bit closer. 2.99 something else.
2.99.
Is that still less than 3? Is my graph below 3? He's at 10,000 now. So is it staying close to 3 from now on? It's hovering around 3.
At one point it was above 3, it was at 3, and now it's gonna.
There you go. Look at this. Right here, at this point right here, it was above 3. Then it hits this point and drops below and hovers around forever this way. So this part, and by the way, you can find this by sign analysis. You can actually test between here and here. You'll find it's above. But the trouble with sign analysis, it says it's above the x-axis. In this case, yeah, that's above the x-axis, but also it's above what? 3. So you could actually test points there. Make sense, guys? Now, before I close down, I've got a few questions about this. If someone answer this for me. All of a sudden you see this on a quiz. One problem. And you got the graph. You feel good about the graph. Now all of a sudden, on the side, I have this. Give me an approximation for this. I ask him to put in 10,000. What should R at 12,000, whatever up there, if you should go back and put it in the function, and crunch it out, what should that answer be close to? No. 3. Is it close to the horizontal asymptote again? I don't care what number I give you out there. It's going to be close to 3. You don't have to plug it in directly. The graph shows you you're close to 3 out there. Okay? Woo! Now some questions. Here goes. Calculus. Graph is done. I got all that information there. First question. Find the limit as x gets large of this function based on the graph. What response would you give me now since you have the graph staring at you? As x gets large, that means you're walking this way forever on the x-axis and you're pulling that red graph along with you. What would you say the limit is? What's the graph doing as you walk that way forever and you pull that red graph along with you? What's it doing? Is it getting closer and closer and closer and closer to 3? That's my limit. Now, why am I calling it a limit right now? Will it ever get to 3? No. No. It's getting close. It'll never touch 3 again. It touched one time at 6. A crossover point. Now, answer this for me. Number 2. Find the limit as x is approaching. Let's try the other end. Now you're going this way forever. Please tell me, what is my graph doing as you pull it along the red? Get graph hold. You take it this way forever. What's my red graph doing? It's approaching 3 again. Except this time it's on top of 3. over on the other end, it's below 3. That's why you gave me an answer of how much, Mr. Park, 2.99 something, over on the other side. This one, the limit is 3 again, Mr. Park. Please do this for me. I'm gonna try something, a number out here. We tried this. Now to the left, try this please for me. Put that number in and tell me what, if you put it in here, my function, see what R at negative 10,000, which is way out there, what's it close to? Don't you mess up.
I'll be fast, sorry.
R at negative 10,000, way out here.
Three.
How much?
3.
3 point something?
Mm-hmm.
3 point what?
3.000.
Oh, 3.00 something and 0.00 what?
0006.
0006.
6. Mm-hmm.
Is that above 3? And the other one on the other side, you give me like 2.99, something that's below. But am I actually approaching 3 on both ends?
Mm-hmm.
Am I, guys? Am I approaching 3 from both ends? Once I'm below, once I'm above, and he's validated this for me. Beautiful, those are my limits. Still approaching 3 on both ends. And number 3, now here's where my mathematicians are gonna come in. I like to find the limit as x is approaching, here we go guys, negative 4 of this function. You're approaching negative 4. You're not approaching infinity. You're approaching, I give you a set number. And I see negative 4 is right here. I like to know, as the graph gets close to it, what is my graph? How's it behaving? Now I'm going to give you an illustration. I could be approaching negative 4. I can use the black marker to hold up for me. Let's try green. Black. I could be getting close to negative 4, approaching it from that direction. That's approaching negative 4. Can anyone tell me just from that direction, what's my graph doing? The closer I get to negative 4, you would say the graph is getting, what's it doing? When you go out this way, what's my graph up there doing? The closer I get to negative 4. Describe it for me. I hear it. It goes up. Does it go up? The closer I get to negative 4, is it going up? So I would assume that's positive infinity.
It also goes down.
Now, oh, that's what I want to hear my mathematicians say. Wait, Professor, I saw you're approaching negative 4. Professor, suppose I approach negative 4 this direction. That's getting close to negative 4. Now what's my graph doing? The closer I get to negative 4, oh, my graph's down here.
Should be negative infinity.
Now it's negative infinity. So which is it, Professor? Is it positive infinity or negative infinity?
Oh, limit does not exist.
No, limit may not exist, but I want something else. If I want to specify exactly which one I want, I'm going to use something called a little superscript. It's not an exponent. If I put, where am I? Down here. Negative 4 from the left, a little negative sign, I want this one,
Yeah.
where it's on the left of it. And guys, what was it doing on the left as I approached negative 4 from the left? My ray graph, was it up here? Which is approaching positive infinity. If I was asking, though, to approach, as one of my mathematicians was telling me to do, find the limit as x is approaching negative 4 from the right, and show you that I want the right, not the left, a little superscript of a positive sign. And that is the negative infinity.
If we take the limit but with no subscript,
It does not exist.
it does
I
not
heard
exist.
you. I heard you.
Okay.
I heard you. Those are my limits. We're getting to some heavy, heavy stuff here. Limit of this, and limit of that, this and that going on. Jeez. Mr. Park. I'm gonna ask my students to do this. Guys, does it look like there is a local maximum in here somewhere? Looks like there's a local maximum in there somewhere. There is one. I can't find it. He could find it using calculus. Specifically, where is it? I would not ask you to find it, but I might say, is there one? You just put yes or no. Yes, there is one. Is there a local min anywhere?
No.
No. There's a local max though. Is there an absolute max? No. Absolute min? No. That's the way this graph looks. And there's a beautiful, beautiful example of a rational function with a few little details thrown in on the end here. Lisa?
You mentioned that the graph is approaching but never get equal to zero, not the 0 to 3, just because the graph is discontinuous.
Yes.
Okay.
Are you talking about over here?
Yeah.
Right here?
Yeah.
Yeah, it's discontinuous. Now, if this were a polynomial function, which you guys will be tested on Wednesday, you would have to do this. You have to connect all these points. All the points would have to be connected. You've never seen a graph where it's disconnected. This thing has 3 separate parts. A polynomial function does not do that. That's why they're easier. This one's crazy. Mr. Park, can you think of anything else from calculus I should ask him? I think we did a pretty good job on this one. I think this one worked out better than the one I did before the break. Yeah.
So if we were asked to find the limit of the other side,
Oh, got you. Hang on. Which side do you want now?
the right side. So at three,
Limit
three.
as, oh, the 3. You want to try 3?
Sx is
Here we go. Hang on. You want to find the limit, mathematicians here. X is approaching 3. Now it's going to approach 3. Now, from which side would you like to be approach?
both.
Okay, let's try that first.
Okay.
Beautiful question. Guys, here's 3. She wants me to approach from the left. Gotta stay on the left-hand side of 3. Is this the piece of the graph she's looking at? To the left of 3. How would you describe what's it doing? Negative infinity. Wow. You guys aren't ready for math 7 after all this. X is approaching now 3 from the right, superscript. And that would be now this piece. That piece is to the right of 3. And what's it doing? Positive infinity. Thank you for asking that. Mathematics. How many students plan to do Math 7 after this? I see most of the hands going up. I know all the Math 7 instructors. They know me. We talk. You wouldn't believe in my office, where some of you guys met me today. My office sometimes is packed with instructors. We're all in there talking. Randy, did you have Lisa? Yeah. Did you have Lisa at Math 2? Yeah, I had Lisa. How's she doing? Did you have Aiden? I said, yeah, I had Aiden in Math 2. He's in your Math 7 class right now? Yeah, he's in there. Is that the way he's in there? That's all? That's all I can say right now. He's in there. I'll find Aiden. See why. What's going on? Because you're ready for Math 7. I'm not working this hard just for you guys to walk in and not be at the top of the class. You should be at the top. Yes?
Backtracking a little bit, you could guarantee or figure out that the inner portion of the graph is a parabola because you look at the denominator and it's like sort of its own independent graph where you see that it's quadratic.
Oh, you see a quadratic up here, and that might give you a hint.
Yeah.
One piece of it may be a parabolic form.
Yeah.
Okay.
Is that a valid?
Not always, sometimes.
Not always.
Guys, make sense? Now, I'm gonna stop here and give you a hand up for just a brief introduction to chapter 4. Chapter 4 is not this.
Yeah, it's.
Not right, exactly. Not this. Now, on your exam on Wednesday, you have one application problem. I have a choice as an instructor. Should I give them a fencing problem and ask them to maximize the area? Or should I give them a projectile being something tossed up in the air and it forms a max and find the maximum height up there and how many seconds it takes to get up there and maybe how many seconds it takes to hit the ground? It could be one of those, a fencing or a maximum height type problem. Have a choice. Am I going to tell you which one? No. You got to be ready just in case. Who knows? I may give one for an extra credit and leave the other for the one that was supposed to be on the test to begin with. I might. I'm not saying for sure. I've got a beautiful test constructed. Oh, it is nice. I checked and I'm being very honest. I checked UCLA. I checked USC. I checked the AP pre-calculus class they're offering now in high schools, and that, of course, if it's taught correctly in high schools, is tough. Advanced placement pre-calculus is now being offered in high schools. I looked there, there's samples. I went to, where was it? Not MIT, Stanford. I went to Stanford to see if they had released anything. I'm ready for you. I am ready for you. Guys, any concerns here? Pretty good on this? Okay. Now, Wednesday, you know me, I gotta take a little time to do what I gotta do. My time will be cut very short Wednesday. To do what I gotta do in chapter 4 here, which you're gonna get a handout tonight. Mr. Park, help me out. Hayden, you wanna help me out?